Here we are with 1 for day 3. We wrapped up all of our graphing adventures in day 2. So day 3, we'll be looking at writing quadratic equations. What we mean by that is if I gave you a little bit of information about a quadratic, could be in the form of a word problem or not, right? Be ready for both. It wouldn't change the math as to how you do it. And you write the quadratic, the actual function that would fit the data that was given, okay? Now you kind of got to roll with whatever you have. If you were given the vertex, which is a common thing, go ahead and take the data that you have and plug it into vertex form. Seems like a common sense thing, but it actually is kind of a big deal. That, like, okay, if part of the data that I'm given is this potential quadratic equation's vertex, oh, let's just go to vertex form and get the process of writing the equation started that way. If you were given X-intercepts, those always go right along with the quadratic's factors. So if you have X-intercepts, use factored form. Okay, if you needed to refer to those, go ahead and take a minute. They're right at the beginning of 1.4 day. I know they're in day 2. They may have showed up a little bit in day 1. But I know they're in day 2 when we did like the beginning of the graphing stuff, and it said, hey, here's how you graph a standard quadratic, a squared plus bx plus c. Here's how you do it in vertex form, and here's how you do it in factored. Okay? You'll find this case, right, that basically we need one of these two scenarios. We need the vertex, and we need one additional point to use as our x and y values. Or we need the x-intercepts and one additional point. Okay, those are kind of the two scenarios that we'll focus on. Kind of begs the question, is it possible to find the equation of a quadratic without knowing the x-intercepts or the vertex? It is. It's a lot harder, but it's possible, and we're not going to do it today. Okay, we're looking at one of these two scenarios. For example, okay, there is the vertex and one additional point that it goes through. Okay, so now this first part you would not need to write out every time. This is just so you have it in your notes. Y equals a times x minus h squared plus k. That's the vertex form of a quadratic. A, which is really the whole process that we're about to go through, is about finding A, that number that determines the direction up or down and the width, wide or skinny, of this quadratic function. We got to figure out what it is because at the moment we don't. All we have is where the vertex is and then one additional point. Okay? Now I just go through piece by piece. My y value is 1. That's where the last part of the notes was saying, hey, that additional point, use that for the x and y variable because you have to have numbers there. Because you'll see we're going to solve a single equation. So we can only have one unknown, and on every single one of these, whether it's factored or vertex, the unknown is going to be a. Okay? So -1 went in for x, and then -2 and 5 goes in for h and k, because that's your vertex. And you're all set up at this point. See, the parentheses would simplify to 1, because that would be like -1 plus 2. The square doesn't really matter. We'll leave it on there. And that would leave us with 1 equals a plus 5. If I were to take away 5. Okay. A would be -4, which tells us that this particular quadratic that goes through those 2 points, it opens down because A is negative, and it's like longer and skinnier. right? Because that 4 is going to make the graph skinnier as opposed to wider. Okay, now I'm not going to graph it, but I just think it's worth pointing out from just looking at A, I know that. Once you go back to your final answer, the vertex stays in, right, -2 and 5 for h and k, but we take the point out for x and y, right? So now it's like a typical function. At that point, you could plug in whatever x value that you wanted to get that particular y value. Okay? So again, that's a vertex form right there. We'll move over to the other scenario. Now, if you're looking ahead, in the notes, we're gonna do 2 of each, okay? For the first 2, I'll write out the equation that I'm using. Notice I'm going factored form because this problem gave me the x-intercepts, right? If I tried to take the 2 x-intercepts that it gave me and plug it into vertex form, it's not going to go well, right? Vertex form works really well if you have the vertex. Factored form works really well if you have the x-intercepts, okay? The y value that I have is -9. That goes with the x value of 0. P and Q are my intercepts. And there you go. From here, we have a single equation with a single unknown and need to solve for it. Whoops, got my A. Looks like we get that A is a half, and then to put it back as my final answer, I would have 1/2 x plus 6 x minus 3, okay? On the very last slide, we'll go over, like, if you wanted to put the final answer into standard form, and these, I'm not gonna do it just because, I mean, again, well, you don't need to do it on every single problem. I think it's fine if you were, like on part A, if you're in vertex form, to just leave your final answer in vertex form, right? It's a perfectly acceptable way to write a quadratic. Part B, leave it in factored form, right? A little preview to the last slide, like on part B, if we wanted to take that and get it to standard, we'd use a process that we typically call foiling, F-O-I-L, to distribute the 4 parts, okay? I'm gonna make sure that you know how to do that if you ever had a scenario where you did need to go to standard form, but for problems like these, completely acceptable to just, you know, leave them in their respected forms, factored or vertex. All right, let's keep rolling. Right here, I'm just gonna dive right into the equation itself. I see x-intercepts, so I'm gonna use factored form. -9 is my y. Right? I'm always looking for A. That's what this is all about. X minus 3, X minus 7. Just simplifying the left side. Dividing both sides by -3, I get that A is +3. So by the way, I didn't mention on that previous factored form when we got that A was a half, which again, I think it's always worth kind of reminding ourselves. That means that that graph would have a, you know, that a quadratic always has that U shape. If A was a half, it'd be kind of wide and it would open up, okay? Here, it still opens up, but this 3 would make the graph a little bit more narrow and a little bit skinnier. Whoops. got to clean it up down here. That's not why. Hopefully you were getting on my case about that. Literally yelling at your computer screen, hey, dude, clean it up. It's not Y, that's A. Almost like you're like yelling at your computer like maybe your dad would yell at a football game or something, you know, just going crazy. Hey, never mind, that's not a thing. You guys, I don't think you get that excited about when you find I make a mistake on the lesson. Maybe you do. I don't know. It'd be kind of funny if you did. Anyway, little sidetracked there. Okay. And again, for now, and really any of these problems, we'll leave it in factored form, right? But I got my A value of 3. All right, let's back it up again. Try another one in vertex form. Y is 13, A is unknown, X is 1, H is 4, K is -5. Take a second there to pause if you need to make sure you're feeling good as to why everything is where it is. Okay, that's a big part that, that's probably the part that can be the most tricky is like, how did everything get where it needed to go? Because I hope you're seeing on like doing several of these examples that the steps to solve, they're not super long and they're not super complex. They're relatively straightforward equations to solve. You just got to make sure everything is plugged in where it goes. Add 5. Divide by 9. There you go. A is 2. So this would be 2x minus 4 squared minus 5. Okay. All right, here's the slide I was referencing earlier. It's like, okay, let's say that, this kind of looks like an answer that we could have gotten from the previous 4 problems that we just did, okay? And again, you don't need to take this approach on every problem. I'm not going to be a stickler and say, hey, every time you write the equation of a quadratic, you have to put your answer in standard form. If you want to, that's fine. I don't care. You don't need to. However, you should know how, right? I think you guys can understand there's a difference between those two things, that, being required to simplify all the way to standard form every time versus just simply knowing how to do it. You should know how to do it, okay? And it's not too bad. You just got to get everything written like you need it. Like right here, x plus 2, that's a vertex form, right? There's a out front that's -3, and then the vertex is -2, -5. Here's really the key. Is to get everything written out like that. The -3 we'll get to in a minute. You got to take care of the foiling. Like that's the big thing. And that would give you x squared plus 4x plus 4, right? I simplified that middle term. You may have gotten that it was 2x plus 2x, right, which I just combined to 4x, okay? So that has to happen first. The next thing, if you have a value for a out front, that needs to be distributed. So that would give us -3x squared minus 12x minus 12 minus 5. And then the very, very last thing would be to deal with that -5. You got two constant like terms at the end. that would combine to give you minus 17. Okay, and I've referenced standard form several times today, and again, I know you have the definition for it in your notes from day 2, but again, that's the form of a quadratic that has 3 terms: squared, first power, and constant. Remember that number out in front of the squared term we call a, the negative 12 in front of just the x to the first power we call b, and then the constant at the end we call c, right? That's what we call standard form. Okay, so that's how you would go. And you can see here, like on the other problems, right? If I had said, hey, your final answer needs to be in standard form, like it's a bit more algebra that we have to do, which again, you don't need to do it every time, but you should know how. All right, here, whoops. Sorry, I meant to put this in earlier, right? To go from vertex or factored form, you typically use the method of FOIL, right, to convert it. All right, so here there's no constant at the end, but take the same approach that my value for a, we need to FOIL first, and a just needs to kind of hold on a minute. We'll get to it at the end. So I just kind of leave that 2/3 out front, and then I get x squared minus 4x plus 3x minus 12. On the one before I did, this is the step I was talking about that I did in my head. It was just to take those 2 terms. If you feel comfortable doing that, that's fine. You wouldn't have to show the intermediate step with the two separate terms there. All right, now we get to our 2/3, and this will look a little bit funny, but just kind of go with it. We haven't seen much of this, but I want you to, just to remind you that a, b, and c, we don't work with them as fractions all that much. They can be, right? The only restriction that we saw on the very first day of 1.4 was that a, right, the number out front here, which in this case is 2/3, that number can't be 0, right? Other than that, there's really no rules about what values a, b, and c can take on. We tend to work with a lot of coefficients that are whole numbers, especially if we're like graphing equations and writing equations. You'll probably come across some word problems where we're like, okay, here's this kind of scenario that's modeled well by a quadratic, and a, b, and c may not be whole numbers. It's fine. We didn't do anything wrong. It's just they can be, kind of depending on the problem. Okay? But this would be your final answer at that point, that you'd say we've got it all the way to standard form. All right? That's the third and final day of 1.4. That's a pretty thorough 3-day stretch on quadratics. The piece that's up next in 1.5 is sometimes with quadratics, we take square roots of negative numbers. We got to make sure we're able to deal with that. So that's what's coming in 1.5.